Hi everyone, we are going to be starting our statistics unit, which you may not have been exposed to anything related to statistics before, so we are going to break this down for you. We're going to give you a lot of information in this unit, a lot of new vocabulary words that you will need to study to understand what we're talking about here. So first we're going to be talking about statistics just with quantitative data only. And what quantitative data is it's data with numbers. For example, height, length, rainfall, age, shoe size. All of these are data that can be represented with numbers. And the reason why we collect quantitative data is to help us understand or make conclusions about a characteristic of a group and how it differs between group members or amongst or between different groups. For example, maybe we are trying to determine the amount of rainfall that a certain city gets compared to a different city. And so we are collecting the amount of rainfall to make conclusions about maybe which city gets more rainfall on average, or maybe which portions of a city gets more rainfall on average, which areas flood more easily. So that's just an example of what we can do with data, quantitative data, to help us make conclusions. So now statistics is the practice of collecting the data and then also analyzing the numerical data to help us draw those conclusions. And when we are analyzing statistical data, we use something called measures of central tendency, which are mean, median, and mode, okay? These values tell you or tell us generally where the center or the middle of the data set is. Whereas we also can find something called measures of variation, which the measures of variation that are the most common are range, interquartile range, and standard deviation. And what measures of variation tell us is how spread out the data is. So we will be finding measures of central tendency and measures of variation and then making conclusions or reflecting on our data values throughout this standard. Now, before we jump into measures of central tendency and measures of variation, I want you to understand that there are two different types of studies that can be done sample-wise. So the population that you are surveying can be called population or a sample of the population. So if you are surveying an entire group that you want to draw conclusions from, then that would be considered, you would be doing a population study. Whereas if you only are surveying a portion of the group that you want to draw conclusions from, then that would be a sample of the population. So for example, let's say you wanted to draw some conclusions from MAP scores from just the algebra classes at Eastview Middle School. If you take all the MAP scores from every single algebra student and in every single class at Eastview, then you are working with the entire population. Whereas if you decide to select a few kids from each algebra class and look at their MAP scores, then you are only using a sample of the population. Now, the reason why we need to know whether we're working with a whole group or a portion of our group is because it actually matters for the mean and the standard deviation when we come to find that. And we'll talk more about that in a moment. But let's go through the measures of central tendency. Now remember, the measures of central tendency kind of tell you where about the middle of the data is. So it will tell you maybe about where 50% of the data lies and the other 50% of the data lies. And so there are 3 measures of central tendency, and the first measure of central tendency is the mode. The mode is the data point that is represented the most in your distribution or in your data set. We'll talk about what a distribution is in a moment, but basically a distribution is a set of data points. The median is the exact middle, and the mean is the average. Now, the reason why I have a star next to mean is actually because the mean is the best measure of central tendency, because the average actually accounts for all the data points, whether we have high data points that are, or actually outliers, which we'll talk about what outliers are. If we have outliers, the mean is going to take that into account, and actually it's going to be calculated into that average. Whereas the median, just being the middle point might not always be the best measure of central tendency. And then sometimes the mode may be too low, and sometimes the mode might not be the best measure of central tendency. So the mean is the one that we're going to trust the most. However, there will be times where we will not trust the mean. Now, I talked about population and sample. If you have a population, or if you're surveying an entire population, the symbol for the mean, and this is a Greek symbol, so it looks kind of funky, it kind of looks like a U. It looks like this. This would be the symbol that you would use for the mean if you were surveying an entire population. However, if you're only surveying a sample of the population, then you use this symbol. It's an X with a little bar over it. Okay? And now for the mean, the population and the sample values are going to be exactly the same. But the reason why we have a different symbol for the population mean and for the sample mean is because when we get to standard deviation, we need to use the mean. But for standard deviation, the population standard deviation and the sample standard deviation will be different numbers or values. All right, so we need to know what we're working with. We need to know if we're working with a population or with a sample. All right, but just know for the mean, these values, so the population mean and the sample mean will always be the same if we're talking about finding the mean. All right, so it doesn't really matter for the mean. Now, measures of variation. There are 3 of them that we're going to talk about. The range, which is just your highest number minus your lowest number in your data set. The interquartile range, which is your quartile 3 value minus your quartile 1 value, which actually you may not know what quartile 3 and what quartile 1 means. Well, quartile 3 is the median, so the middle of the second half of your data. So if we split our data into 2 halves, quartile 3 is the middle of the second half, whereas quartile 1 is the middle of the first half. So if we take the middle of the second half minus the middle of the first half, we will get the interquartile range. Basically, what the interquartile range gives us is it gives us the middle 50% of the data, okay, which that actually shows you where most of your data lies, or half of your data lies. The standard deviation can be found using the following steps, which in our next lesson, we will be actually finding standard deviation. So we will be referring back to these steps. I'm going to have you write these steps down. I'm not going to go through them right now until we get to our next lesson. However, with standard deviation, what we are going to do is we need to decide whether we're dealing with a population or a sample of our population. If we are dealing with a population, we use this symbol. This is a Greek symbol. It's like an O with a hook on it. If we are using a sample of the population, we use a little s. All right, and now population and sample standard deviations are going to have different values. When we're dealing with population and we do step number 3, which is the average of the squares, and we'll talk about what that means in the next standard or the next lesson, we just take the average like normal. All right, it's a normal average. But when we do a sample standard deviation, when completing step 3, we are going to divide by 1 less than what we normally would divide by when we're doing the average. And there is a statistical reason as to why. At this point in time, it might be a little complicated for you to understand. All right, but just like where mean is typically the measure of central tendency that we will trust the most because it gives the most accurate representation of the data, the standard deviation is the best measure of variation, but not always. So I say typically the mean and the standard deviation are the best measures. But sometimes the median will be the best measure of central tendency or the mode. And sometimes for the best measure of variation, it may be the IQR or the range. And we'll learn how to determine when standard deviation and mean would not be the best measures to use. We'll learn about that. And we will talk more about what standard deviation actually means, because there's actually a statistical way to explain what standard deviation is. All right, and then the last thing we will learn about is the shape of a distribution. Now, a distribution is a way to visually represent the data points. So you may visually represent the data set using, let's say, a box plot or a histogram or a dot plot. And if you haven't heard of those words, you will. We'll learn about those. But the shape is a way to describe the data set, and the description of the shape actually helps describe what the data would look like visually. So if we were to graph the data set, what is it going to look like? We are going to focus on 3 ways of describing the shape of the data. We're going to learn about whether to determine if the data is symmetric, skewed to the left, or skewed to the right. But there's other ways to describe the data shape, and we're not going to talk about those, but you may hear down the line when you learn more about statistics, you may hear the words bimodal or unimodal, and we're not going to be diving deep into those terms. But I know that this was a lot of information, and we will be working with all of these things throughout this standard. So hopefully throughout the next parts of these lessons here, you're able to dive deeper into each of these measures.